All right, so I'm going to go over this dimensional analysis with you quickly, and hopefully it'll make some more sense. So we've already done this first one, but I'm going to run through and do it again. So again, speed limit is 75 miles per hour. We want our speed in meters per second. We're starting at miles over hours, so we're going to say 75 miles per 1 hour. And then we are going to make a series of conversions. First, we need to get rid of miles and get to meters. So we're going to look up here and see what we have. Well, we have 1 mile is 1.6 kilometers. So 1 mile is 1.6 kilometers. My miles will cancel with my miles there. And then I'm going to get rid of kilometers, and I want to go from kilometers and I want to go to meters, okay, because that's what I want here. So we'd have to go back to the table on the other slide, but just know that there are 1,000 meters in every 1 kilometer. So 1 kilometer equals 1,000 meters. So once again, my kilometers will cancel out. And then I have my top is in meters. My top here is in meters. I want my bottom in seconds. It's in hours right now. So if I want to get rid of hours, hours has to go on top. 1 hour is equal to 3,600 seconds. I'll do a different color here. My hours here cancel out with my hours here, and I can see that my units that are left are going to be meters per second. So I just have to do the math here, and if I do that out, I come up with 33.3 meters per second, and that is my answer. Okay, so then I come over to this one, and a car is driving down the road at 40 meters per second. They look down at their phone for 3 seconds. How many feet did the car travel during that time? Okay, so my starting point is at 40 meters per 1 second. So I have 3 seconds that they were driving for. So that's what's going to help me get rid of the second over here. So I'm going to do 3 seconds. There's really nothing here, but if I want, I can put a 1 there just to kind of fill it. And you will see that seconds here cancels out with seconds here. Okay. My answer is in meters, but I want to know how many feet. So if meters is on the top, then meters has to go on the bottom. And I need to know how many feet are in a meter. If I come up over here, I can see that 1 meter is 3.28 feet. So 1 meter is 3.28 feet. My meters will cancel out here, and my answer will be in feet. And if I do that out, I come up with 393.6 feet. Okay, so for this first one, again, we have used dimensional analysis to show that this right here is not valid. So D equals AT. Well, D is distance, and that's measured in meters. So I'm going to have M equals. A is acceleration, and it's measured in meters per second squared. And T is time, and it's measured in seconds. So my seconds here and one of my seconds here will cancel out. So that will cancel out with that. And my answer will be in meters per second. And meters does not equal meters per second. Okay, so that's what that one is. Coming over here, the world record for the bench press is 335,500 grams. Actually, that is, I lied. It's just 335,000 grams. Sorry about that. How many pounds is that? So I'm going to start off with 335,000 grams. Okay. And I want to go from grams to pounds. You don't have a conversion for that. You have kilograms. So every 1 kilogram is equal to 1,000 grams. Okay. So my grams are going to cancel out. And I'm going to be left with kilograms. So now I go from kilograms to pounds. And I'm going to say 1 kilogram is equal to 2.2 pounds. My kilograms are going to cancel out, and I'm going to have 335,000 divided by 1,000 times 2.2. And if I do that out, I get 737 pounds. Now, if you, over here, instead of doing it like this, if you had 0.001 kilograms equals 1 gram, that would work as well. So it just depends on how you set it up. All right, and then for this one down here, I presently weigh about 180 pounds. I am working on that. How many newtons is that? So newtons is a measure of force, and weight is a force. So pounds is a force, newtons is a force. So I have 180 pounds. And I need to have a conversion. So first off, we, from this last one, should remember that there are 2.2 pounds per 1 kilogram. My pounds will cancel out. And then if I were to look above here, I would see that every kilogram is 10 newtons. So 1 kilogram is 10 newtons. Kilograms will cancel out. If I do this out, I have 180 times 10, then divide that by 2.2, and you will see that if I multiply it all out, I come up with 818 newtons. And there's your answer. Okay, so for this one, it is a very, very difficult problem, especially this bottom one. So if you don't want to attempt this, don't worry about it. So Voyager is 150.1 AUs from Earth. It is farther than any object man has made. It's been going out for 43 years. And my question is, how many light years away is it? So you'd have to know what a light year is. A light year is the distance that light will travel in 1 year. Light travels very, very quickly. So at 300 million meters per second, light travels. So to do this, we're going to start off with our 150.1 AUs. That's how far away it is, okay? We're going to need a long one here. So then we're going to say, let's convert that to miles. So we're going to say that there are 93 million miles in every 1 AU. My AUs are going to cancel out. Then we're going to say, let's go from miles to kilometers. And we will remember that every 1 mile is 1.6 kilometers. Miles will cancel out. Now we got to go from kilometers to meters so we can get that there. And so every 1 kilometer, oops, I wrote that in the wrong spot, sorry. Every 1 kilometer is 1,000 meters. So kilometers will cancel out. So now I've got my answer in meters. Okay, so then I'm going to go to seconds. And so we need to work. So this is how far away it is. Now we've got to say, well, a light year. Let's kind of relate it to that. So light travels at this speed, 3 times 10 to the 8th meters per second. And so if I want to cancel out this meters and get it into a time, I'm going to use this velocity here. And I'm going to say 3 times 10 to the 8th meters per second. That's 1 second. So I kind of flipped it over. Okay, every 1 second, light travels that distance. Normally, we would write it as 3 times 10 to the 8th meters per second, but I'm flipping it here. And that is so I can cancel out my meters. And so if I do all this out, my answer is going to be in seconds, light seconds. I don't want to know how many light seconds it is away. I want to know light years. So, and I'm going to, so I got to go from seconds to hours. And I know there are 3,600 seconds in every 1 hour. Seconds will cancel out. So now I would have how many light minutes away it is. So I'm going to go 24 hours per 1 day. Hours will cancel out. Then I'm going to go 365 days per 1 year. Days cancel out. My ending here is years. That's light years. And so I multiply all that together, divide by all that. And if I do it out, it turns out that man's greatest achievement is only 0.002 light years away. Not very far. Okay. So when will it be 10 light years away? Well, to do this, you're going to say it has traveled 0.002 light years in 43 years. So that means, so I'm going to do it like this, 0.002 light years per 43 years. If I divide this out, it will tell me how many light years it travels per year. If I do that, I'm going to come up with 4.65 times 10 to the negative 5th light years per year. Kind of a weird unit here, but it's saying it travels that many light years, 0.0000465 light years per year. So when will it be 10 light years away? I'm going to take that number. I'm going to say 10 light years. And I'm going to divide it basically by, or I'm going to show you how I would do it this way. 4.65 times 10 to the minus 5th light years per 1 year. So light years will cancel out. If I divide 10 divided by 4.65 times 10 to the negative 5th equals 215,053. 215,053 years.